Uh-oh.
Oh,
Clean up the speech.
be careful what you say.
Hey, everybody, give me just 1 second. I want to pull this up so I can follow along. Where are we? Tuesday morning, right? Okay, cool. Hey, everybody. As Gene said, I volunteered. I was a speaker yesterday, and I don't know. I like to be in the spotlight, so I volunteered, and I figured I would just try to help move things along and make things interactive and have some fun and learn at the same time. I am definitely not an expert at this topic, so I'll be an expert facilitator. So we are talking today about waste conversion technologies, but as I did yesterday, and I think we've got some time, I'm going to do my volunteers again. Quick, 3 volunteers. They'll be easier. 1, I need 2 more volunteers. We're not starting without 2 more volunteers. 2, 1 more, 3, yay. 4, perfect. Okay, I don't have any donuts and I don't have a slide. So just real quick, each one stand up. What's your name? Organization you're with? Why are you at SERC? But really, like, you could be golfing, you could be at the pool, you could be sleeping. You got up at 8 o'clock or 7 o'clock in the morning to be here. I'd like to know why you are in this room. I think it's going to help these guys as they present to really understand why you're sitting here.
My name's Lloyd Ely with Transcore Recycling in the Tampa Bay area. And the real reason I'm here is we are collecting manufacturer shingles and we're looking for a better outlet for them. We feel like there's a better end market than just putting them back in the asphalt or turning them back into crushed asphalt.
Awesome. Got volunteer prizes.
Morning, my name's Brian Jones. I'm with the City of Roseville, do the collection for the City of Roseville. And just here to kind of network and further our education and different types of, technologies and everything like that, recycling markets. So just want to soak it all in while we're out here.
Awesome. 2 more.
Hey, good morning, everybody. I'm Chris Hawley with the Florida League of Cities, and we represent all 411 municipal governments here in Florida. And we're here to learn about what they should be taking advantage of and how they can partner with other governments to continue to keep their recycling programs going.
Awesome. We met yesterday. I did not know not just your organization, but I didn't realize there was an organization like that. And I got to assume there's 49 more. Which is a great, anybody who wants to, anybody who wants to understand what you can do for the government instead of trying to reach out to every single city in a state, you can go to an organization like that and learn. So very cool. 1 more.
Hi, Kina Corey with the Florida Recycling Partnership Foundation. And I'm here to see old friends and make new ones and also give them a plug because Florida League of Cities, they have a great conference as well. And we've done booths there in the past so that we can educate policymakers about the benefits of recycling and how to recycle right. Do I get my dollar now?
Awesome. I was going to say, awesome. They owe us both. Okay, cool. Let's get started. So, Kenny, you're first, right? I want to make sure. Okay. So first, we're going to hear from Kenny Davis, the CCO and CMO of Resynergi, if I'm pronouncing that correctly. And he is going to talk about decentralized deployment of chemical recycling, an effective approach to addressing plastic waste feedstock challenges. Kenny, come on up.
Thank you. Let's see, is this good height? There we go. Hi, my name is Kenny Davis. I'm the Chief Commercial Officer of Resynergi. We are a chemical recycling company, and we use microwave pyrolysis to turn plastic waste into pie oil, which we then turn back into plastic resin to complete the circular economy. And let's see, here we go. Nope, that's the wrong direction. There you go. So the question is not if, but how fast this industry can bring us the circular economy. And what I want to share with you today is why I think that the fastest way to large scale adoption is actually through small modular building blocks. We all know that the plastic waste problem is approaching a crisis. Most of it does not get recycled. We're on track to double the 460 million tons of plastic that we make today by 2040. But we already have the technology to do chemical recycling sustainably and profitably. So all of this plastic can eventually become, can be made into oil. And the good news is, while the amount of plastic is going to double by 2040, the speed of recycling is going to quadruple by 2040. And most of that is going to be led by chemical recycling. So the nasty plastics like the films and flexibles with the dyes and all that stuff, all of that will become the oil fields of tomorrow. And there's a lot of money to be made in that, which will propel this industry forward. And that's not even accounting for the carbon credits. So the free market is ready to adopt pyrolysis and chemical recycling today. The bottleneck is actually not demand. The bottleneck is supply. We just can't make enough. I've got a partner who has told me that her company would take 1 million tons of pie oil if she could get her hands on it today. So that's like $10 billion for one company. There's 80% of consumer packaged goods companies that have made a commitment to having their packaging made from recycled materials, but there just simply aren't recycled materials to make most of the plastics. Now, I happen to have some background in this. So I want to share a personal story to just kind of give you a sense of the math and why it is that I believe that the free market is ready. It's really just a matter of production. So about a little over 10 years ago, I ran a division of Hasbro Toys, the toy company. And even back then, I relaunched the Furby and we made the packaging entirely sustainable. And so I remember going through all of the hurdles of figuring out how would we do the P&L to prove that this is a good, positive ROI. So I want to give you an example using something from today. This is a Barbie that I found on Amazon for $19.99. I'm not betraying any of Mattel's secrets. I'm just taking an educated guess at the numbers. I did call my old friend who's the SVP of sourcing who was the SVP of sourcing for Hasbro, and he verified these are good guesses. So we took a look at it and we said it's probably about $5 for Mattel to make a Barbie and land it at an Amazon warehouse somewhere in the United States. Of that $5, about 50 cents would be the packaging. And most of the packaging is cardboard. So that's already going to be recycled, might even be made from recycled materials, or it's recyclable, might even be made from recycled materials. So it's really just that plastic window. And you can't use mechanical recycling for that because the Barbie, you got to be able to see that Barbie. She's got to look majestic. So that plastic window costs about 10 cents of the 50 cents. Now, it's made from crude oil today, but if it was to be made from pie oil at today's prices, which is like 2.5 times what it costs to make crude oil, that window would probably cost about 15 cents. So you're adding 5 cents in cost of goods sold. So math, and the P&L, and figure out that for every 1,000 Barbies that Mattel is selling, they would need to sell an additional 5 to hit break even or to cover that green premium. They sell 6, they're making a profit. And in the context of a larger sustainability campaign, selling 6 more Barbies is easy. So that would pencil. So this is really being driven by the free market. Government subsidies are great. EPR is fantastic. But what I want to make sure is clear is we don't even need that to get started. It's really a matter of supply. So why is it that environmental groups don't trust us? Why is it that the governments aren't throwing money at chemical recycling, or mayors aren't inviting chemical recycling to set up shop in their communities? And the reason is there's a perception problem. There have been some notable overpromises about chemical recycling coming in to save the day, and we're going to take all your plastic and recycle it, and this on the back of decades of hype that sort of replaced reality. And there's a lot of cynicism out there, and we have to address that. We have to own that this is the industry that we're in, and if we're going to change people's minds, we need to own up to it. The second is there are more and less polluting ways to do pyrolysis, and unfortunately, there have been some that tried to rush pyrolysis out in more polluting ways. The press took note of that. And again, it gave us a black eye. And then lastly, big plants look scary. I would not want to look at that through the dining room window. And so we're like that middle school kid who can't figure out why no one will talk to us. And we got a big sign on our back that says deceptive, dangerous, and dirty. So we've tried to rethink the entire approach to bringing pyrolysis to market from the standpoint of how can we do this in a way that is friendly, safe, and clean. And so at Resynergi, we've built a module, a small module that's so safe that it can be operated indoors, no smokestacks. Everything is trapped inside of a closed loop system until we decide that we're going to take it out. And this, we've sort of put ourselves in the place of saying, we'll know we're successful when mayors are inviting us to bring jobs to their communities. So we can do all of this. We as an industry can do it, Resynergi can do it. And what we're talking about doing is creating oil. It's basically just oil. Once we've turned it back into oil, it's indistinguishable from crude oil, but with a carbon footprint that's 68% below that of making virgin oil. And we can do this with no hazardous waste, with fewer emissions or fewer VOCs than a passenger car, all in a light industrial setting where we're creating great entry-level manufacturing jobs. And we're cleaning up trash, and we're even destroying those complex chemicals like PFAs, the forever chemicals. The secret sauce is that we can turn plastic into oils in just seconds. So it's ultra-fast pyrolysis. So this was our co-founder figured out 10 years ago how to do this at hyper speeds. And so what we're able to do is create a reactor that's 8 feet tall. It's about this wide. It's like a industrial size washer and dryer. And the oil moves through it so quickly that 1.25 tons of plastic can be turned into oil every day in that small machine. So here's a look at what the pilot reactor looks like. So we commissioned this in 2021 and ran 10,000 hours of tests on it. And all of the oil that came out of that test was then shipped to partners. So we have a Fortune 100 pet chem partner, and we passed all of the safety and quality requirements for that pet chem partner. So in 2024, we began pre-commissioning our first module. So the module is that blue skid, and you can put 4 of those pilot-sized reactors on the module. Now, sort of the normal, call it engineering approach is to make a bigger reactor now, because the bigger reactors from just a chemical perspective would be more efficient. But we would have had to start reinventing from scratch. So, the sort of theory of using modularity for rapid deployment, we just put 4 of those pilot-sized reactors on one module. And that de-risks production, because every time we make a new reactor, we're doing it better, faster, and cheaper. And then not only are we de-risking production by using this sort of modular approach, but we're also de-risking operations, because we can do maintenance on one reactor while the other 3 are running. And then we're de-risking production, we're de-risking operations. We can also de-risk deployment. So each one of these modules can fit on the back of a truck. We can take the module to where the trash is. So now you're not shipping trash, which is expensive. And the same team in a central location is developing module after module. So again, you get that sort of team learning over time. And with the sort of prefab modules, we also have learned how to do installations. So when that module arrives at the site, you don't have to have a whole new architectural plan, because each one of it's been done before, and each one of these comes with a playbook for how you install and create a factory. The best part is we've partnered with Lummus Technology. Lummus is a fixture of oil and gas technology since 1906. So when someone purchases a module from us, they're actually purchasing it from Lummus. So Lummus will sell, service, and warranty the modules. And then beyond that, Lummus has a worldwide data monitoring capability. And so because every module is the same throughout the world, they're learning about all of the modules from each of the modules. And that gives them the ability to do preventative maintenance, predictive and preventative maintenance. So again, the whole point here is we believe that the small building blocks is how we get to large scale adoption. And so you can literally, yourself start small and grow big. I'll go back to toys. One of the reasons why Lego is by far the best-selling toy of all time is because you can build anything with Legos, anything of any size with Legos. And the same is true in any sort of modular approach. So when we, we're de-risking all of those other components, we're also just de-risking the capital structure. So when you start setting up a mega plant, you're actually generating revenue early. And as you're adding capacity, you don't have to shut down the system. So you're continuing to operate as you grow. There's two ways that someone can join us on this journey. The first is, of course, purchasing modules from Lummus. The second is we're also going to purchase our own modules from Lummus and develop sites. We've begun in Sonoma County, California. We've got our first site going live in a few weeks, actually. You can see a picture of it right there. And we're going to be looking for partners to bring us feedstock as well as do JVs as we set up our own factories throughout the world. So with that, let me leave you with a behind the scenes look at the Resynergi module from our CEO, Brian Bauer. He's not actually here. We're going to show you a video.
Oh, sorry.
Yeah, we got a video. Real quick video.
At Resynergi, we believe in a world where waste isn't wasted. Our vision is simple. Capture plastic waste and make it into something useful. We've designed a solution that's compact, efficient, and scalable. We call it the Resynergi module. Our modules are small enough to fit on the back of a truck, pre-assembled for easy transport, and can be set up in just a few weeks. This flexibility allows us to tackle plastic waste right where it's generated. And as your community or business grows, our system can grow with you. Start small, scale big. That's the power of Resynergi's modular solution. Here's the problem. More than half the plastic you put in the recycling bin can't actually be recycled. It ends up in a landfill or gets incinerated, which is a tragic waste of resources and money. That's where Resynergi comes in. We take hard to recycle plastics. We'll take anything with recycling codes 2, 4, and 5, as well as mixed plastics and even materials with high contamination. The process begins by shredding and pelletizing the plastic. These pellets then travel through a tube to our patented reactor. Here's the magic. Our system uses microwaves to heat the plastic in an oxygen-free environment. So there's no combustion, no burning, no incineration. The long polymer chains in plastic are broken down to short hydrocarbon molecules, monomers and oligomers that we condense into a liquid oil. Think of it like disassembling a Lego structure into individual bricks so that you can later build something brand new. Plastic fillers and contaminants, which make traditional recycling very difficult, are separated out and sequestered into concrete. In just seconds, 70% of the plastic becomes oil, ready to be sent to petrochemical facilities to create new plastic. Unlike traditional recycling, this process can be repeated indefinitely because we break the plastic down to its simplest molecular form. Nothing goes to waste. The remaining plastic fillers become concrete, and the gas powers our operations through cogeneration, so we don't have to pull electricity from the grid. There's no hazardous waste. There's no waste at all. Everything has a purpose. And here's the kicker. This process reduces the carbon footprint by up to 68% compared to plastics produced from crude oil. We're not just about recycling plastic, we're about building better communities. Our process creates good manufacturing jobs, is quiet enough for cities, and emits fewer VOCs than a passenger car. Here's the best part. We have partnered with Lummus Technology, a leader in process technology for over 115 years. Lummus is the exclusive design partner and supplier of Resynergi modules. You can contact Lummus directly or through our website at resynergi.com/Lummus. At Resynergi, our long-term goal is to recycle all plastic and do it in a way that is friendly, safe, and clean. I'm Brian Bauer, co-founder and CEO of Resynergi. Thank you for joining us on our journey. Resynergi, we believe in a
I'm going to start off with my own question because I have the microphone. That's really cool. But in my little brain, something is missing and I don't understand it. It's like you have a magic box. What's the problem? Why isn't that magic box everywhere? And why aren't you just eating up all the plastic out there in the world? And why are you and Like what is the problem? Like why is
Yeah,
this
why,
effort?
why isn't it going faster? So some of it is just the point in time where you've reached us. We're not the only pyrolysis chemical recycling company. I think we are pretty much the only ones who are doing this modular approach the way that we're doing it. So you are seeing chemical recycling spin up. It's doubling from this to this. So, you're not noticing how fast chemical recycling is being adopted, but it is. There's companies like Brightmark out there. So the simple answer is, I think chemical recycling is coming. I think we're contributing to it. We just raised our Series B 2 weeks ago. It is happening.
So obviously everyone needs money. You're raising money, but like, do you have to buy the plastic? Is the challenge? Like, why isn't everyone lining up
So-
with their trash to dump in your parking lot?
Yeah, no, I appreciate your continuing to push. The technology is, more difficult to deploy than it looks. So
Okay.
it's not that the engineering theory is wrong. It's not that there's something hidden and, that I'm not saying that doesn't actually turn the plastic into oil. It really is that it's more difficult than it seems. So there've been big companies, Chevron, Exxon, who've been trying to do it for 10 years. There have been large investments. I'm sure someone from Waste Management's here by companies like Waste Management. Pure Cycle was a company that was invested in by Procter and Gamble. So they're out there. They just haven't been able. And this, when I mentioned that we have a perception problem, there were a lot of promises about how big chemical recycling was going to be by 2025, and companies like Shell have actually had to walk back promises of being able to make plastics that are recyclable by 2025 because the chemical recycling capabilities aren't there yet. So it really is, I would say, it's no longer a technology problem, but it is I would call it more of an engineering problem than an R&D problem. The plants just aren't built yet.
Gotcha. First of all, I'm doing shameless self-promotion. About, I don't know, 10 years ago, I bought 15,000 tape measures with my name on it and then didn't do anything with them. So now that I'm flying out here, I'm like, well, I'm gonna give these to everybody. So I don't have a booth, but you're all getting one. You're getting a handout. But by the way, my wife freaking loves these. Put them in your glove compartment. Whenever you're looking at buying something, you're like, I wonder if it's gonna fit in my house. Now you know. What are the questions? Yes.
Marty. My question is, and I know this is pretty controversial, and I'm giving my age out to say that in the early 90s, I've been seeing pyrolysis, touted, and many projects fail over the years for a variety of reasons. One of the things I didn't quite see in your presentation, and one of the big challenges I've seen, is the feedstock preparation. So your module is really the conversion itself. It's not the front end preparation of material to feed into it. Is that correct?
That is correct. So first of all, I want to say I remember the 90s as well. They were lovely. And yeah, so when I talk, so actually let me talk a little bit more, because I think this also goes to that question of why now, and what am I missing? What makes you so hopeful this is finally going to happen? Because the promises actually date back to the 90s and the technology dates back to the 60s. So why now? And I think that your question is relevant to it. It's not only the pyrolysis that has, it's not only the pyrolysis that has advanced, it's also, I get to use a magic word, it's AI is helping make this possible. So the sorting of the plastics is being done more efficiently. We can take, so it used to be that you couldn't take any contaminants. We can now take about 5% contamination. But even getting down to 5% contamination, if human beings are picking out the plastic, gets very expensive, and then the economics don't work. But today you've got AI and infrared, cameras that are looking at the plastic, and pneumatic robots that are sorting it for you. And so we can actually get a waste stream that has had almost no human touch that we can then pyrolyze. So it really is, when you're asking the question of why now, when this technology is, in theory, been around since the 1960s, a lot of it does have to do with automation.
What other questions? Oh,
So,
awesome.
so if we
take the plastic, okay, we're using probably the color, I'm sure,
Mhm.
which is your better fuel, and we granulate it and we put it into your system, and then the system produces diesel fuel?
It produces naphtha and diesel, yeah.
Produces what? I'm
It's
sorry.
it's a spectrum of hydrocarbons, but mostly naphtha and diesel.
So you can take this diesel and put it directly into your vehicles?
Ye-
Like I did biodiesel and out of waste vegetable oil, built the plant and we ran biodiesel in our trucks. Is that as simple? I mean, are you producing a diesel that I can put right into my trucks?
Yes, so simple answer, yes. Let me explain. The oil that we produce is a mixture of different weights of hydrocarbons, and we call it oil, pyrolysis oil. We send that to Louisiana to, be cracked, and then it's for efficiency purposes, that makes sense. But it's not a technological hurdle to put a catalyst into our system and just, make diesel fuel. And we actually did experiment with that.
So have you tested the diesel coming out to see if it avoids any kind of manufacturing?
Yeah, we have done, so on that pilot plant, actually early on, what we did is we would catalyze the oil and then make barrels of diesel, which did go directly into trucks.
Bill, the national, all these truck lines are okay with it.
Yeah.
What's the smallest machine that you have available to put in there?
So we're only making one size module. So it's the size of a skid. It's the size of the shipping container on the back of a truck. And again, the repetition, the sort of Lego block theory is part of the efficiencies. So, while we've had many requests to create different form factors, our commitment is to create that Lego block.
Question here.
I was just curious, you've got the plant in Sonoma. What were the permitting challenges you had in California and what was the biggest hurdle? That's where we're from, so.
You remember that song, "If you can make it here, you can make it anywhere"? It was really tough. And actually the reason why we're still a few weeks away from, we're pre-commissioning, but the reason why we're not commissioning is because we still have a few weeks to get our air permit. The good news is, all of those sort of safety requirements that I talked about are real. And that was part of our thinking. We started in Sonoma County. That was actually, we sort of backed into this. And for anyone wondering, I would not recommend it. California is really tough for getting permits. And I do hope that loosens up because California is where a lot of this environmental technology is actually coming from. But it was very, very tough. But in the end, what we decided was we really do believe we have something that's so environmentally pure that we'll pass. And when we do, we'll be able to take this anywhere. So we were able to get the use permit, which is, fire and safety basically. And we're working on the air permit. We're less than a quarter mile from a school. So when we get that, we will basically proven that we can be permitted anywhere.
So use and air were the only permits required?
Correct.
Okay.
Correct.
And then what's Sonoma County doing with the PIO?
We ship the pie oil to
Louisiana?
petchems in
Okay.
Gulf Coast, yeah.
Is it in barrels or what's that process look like?
We've done it by truck. Eventually we want to do it on rail.
Okay.
Yeah. And actually you're just in case people are curious. So we've done the math on some of these larger plants require shipping trash to the plant. And it's substantially less expensive to ship oil, especially if you're doing it on a rail.
We got one more.
Raise your hand if you have questions. We know we can go in order.
First off, I'm really excited about plastic to plastic. That's recycling, and it's in different worlds. How that's defined in the chemical arena can be a challenge because of a word. But two things. It was asked about why aren't people lining up for you to take their trash, but it sounds like there's a pre-processing cost. So is the model for your facility to buy that plastic that's already been sorted, or are you going to have to do a secondary module that's a sorting, shredding, sorting situation. So then it's clean enough feedstock to feed into your system.
Simple answer is it needs to be done. The more, in-depth answer is, we just have our first site and we're going to figure out how to, let me answer your question this way. For our first site, we're getting fairly clean feedstock. The partner that we're working with has great sort of AI-driven sortation. So all we need to do is a quick visual sort and then we're able to process it. So we shred it and we pelletize it, and then we have a pipe that just sucks it all up and feeds it into our system. As we expand, I think the economics that you're talking about, as well as the sort of division of labor, will become, all I can say is it's interesting. It's something I'm talking to a lot of the MRFs about. So to explain what the question is, the MRFs aren't necessarily separating out their films and flexibles, because right now they're just going to landfill. So why not just put it in the dumpster with everything else? So if you're going to add that step, who pays for it? And when you add that step, so right now our model is, if it costs you less than landfilling it, it's a benefit to you and we'll take it. And in Northern California, where landfilling is really expensive, it's an easy sell. Over time, we do need to figure out, who's going to pay for call it the secondary sortation, and what is the pricing model, who's paying who, et cetera. The good news is the oil commands such a premium that while those negotiations are important, at the end of the day, so long as the price of pile holds up, and the price of operations goes down, which it will as we get more and more mature, it's not that rounding error isn't going to be the thing that drives the industry.
It just seems like you need really clean product for your system, which is not going to be post-consumer necessarily, be post-industrial.
No, we're taking 100% post-consumer. So the amount of contamination that we can take is about 5%. And with today's sort of automated sortation, we can get to that easily. So we can take twos, fours, and fives, which is the rigid plastics, it's the films and flexibles, and then the polypropylene. And any of these technologies can sort them automated at this point.
Thank you.
Yeah, thank you for your presentation. I really like this modular design of this whole system. My question is, do you have any specific numbers on the energy consumption per ton processed? And also, did I get it right that you use pellets as an input material? And does the bulk density have an impact on the energy consumption there?
Yeah, great question. So we use the grid. Actually, we have solar panels on our roof right now, but we use outside electricity to turn on the machine. But once it's running, we're using the gas that gets put off from so about 25% of the mass becomes synthetic natural gas. And so we have a cogenerator, and the cogenerator is run by that synthetic natural gas. So we're not pulling any electricity once we turn the machine on. And if we run the machine 24/7, it continues to run without electricity. And then the pellets. So what we're doing is we on our side, we take the films and flexibles, they can be long strands of bags. We will shred them, we will pelletize them, and then they go directly into our machine.
We're gonna move on, make sure we get through all the presentations, but then we'll do Q&A at the end. So if you do have more questions or something comes up, we'll have some time at the end. Awesome. Thank you, Kenny. Our next speaker is going to be talking about solving the world's landfill challenges one city at a time. Patented green tech achieves 85% landfill diversion into sustainable fuels. And with that, I give you Mark Brown, CEO of WastAway.
Got directions here for the laser. Good morning, everyone. Glad to see you this morning. Glad to see a few of you showed up and aren't out practicing for the golf later this afternoon. Let me have a show of hands so I can understand the audience a little bit. Who represents either a community, waste supplier, someone that's looking for ways to responsibly dispose of waste. So some of you, and then who represents equipment suppliers or technology suppliers that are looking to work with other people? Okay. I'm not sure what the rest of you are up to. You may all be waiting for the golf game, but anyway, we can work with both groups. For those of you that have a waste problem or looking for waste solutions, WastAway would love an opportunity to talk to you and see if we can work together to come up with better solutions for responsibly handling your waste. For those of you that are technology providers, only about 50% of the equipment that goes into a WastAway system is our proprietary technology. So we're always looking for technology partners that we can work with to bring in other pieces of equipment into our process. So whichever side of the equation you're on, we'd love a chance to talk to you about it. So real quick, a little bit about WastAway. We are a leading green tech innovator. We've been around forever. We've been around since, actually the parent company, Bolden Corp's been around since 1959. So we're not a brand new company that's recently formed and raised money or what have you. Core business, I'm actually the CEO of Bolden Corporation, which is our parent company. Our core business, we've been doing automated equipment for the nursery and horticulture industries since 1959. And since 2002, we've been focused on waste coming out of a collaboration with the U.S. Army Corps of Engineers and some proprietary technology we developed there. We do have a plant up and running in Morrison, Tennessee, just south of Nashville, and I would invite you to come visit sometime when you're in the area, and love to show what we're doing there, and we'll talk about some of the other projects we have in development in a few minutes. Let's see, and Todd does great slideshows for me, and then I ignore them, so you never know. He never knows what I'm going to say when I'm up here, but I guess I did skip over the fact that our technology at its core, and we'll talk about it more in a minute, but we remove the metals, the plastics, the glass, the things that can be recycled in a given area, and then we transform the remaining material into a variety of biofuels and or soil amendment products, and we'll talk about some of that in detail in a minute. One of the important things that we focus on is 85% landfill diversion. There are a lot of diversion technologies out there. We can do typical MRFs, we can do curbside recycling. There's lots of ways to divert waste from a landfill. But if you're only solving half of the problem, if you're a community, you've still got a problem. And while we say 85%, we can get 85% landfill diversion in beneficial reuse, but even that 15% that's left is typically inerts. It's going to be the rocks, the glass, some of the inert material. In a lot of cases, we can actually maybe not be able to sell that material, but at least find some way, at the very least, maybe it can go into a C&D landfill as opposed to a class 3 or easier way to get rid of it. So for those of you that represent communities, who wants to be responsible for siting and permitting a new landfill in your community? Well, I didn't get any hands on that one. Surprise, surprise. And this number keeps going down, as we know. You're all waste professionals, or most of you are. And so, 1,250 landfills, and that number's being reduced every day. In Middle Tennessee, where I'm from, we have a huge regional landfill called Middle Point that's been taking in waste from 31 counties, and it's reaching the end of its life, and they want to expand it, and the host community says no. And so we've got this huge problem with much of Middle Tennessee looking for new alternatives. And there are some other small landfills in the area, but when you divert all this regional waste, what had a 20 or 30 year lifespan suddenly has a 2 or 3 year lifespan. So But anyway, as we know, the public is tired of landfills. They're definitely demanding a better solution, and we believe WastAway can help provide that. So the technology works. Whenever we're talking about technology, that's important to be sure that it works. I think I said a minute ago, it began as a collaboration with the U.S. Army Corps of Engineers working on solutions for Army bases and particularly European bases where they need to get rid of the waste overseas. We have a number of awards, R&D 100 winner, U.S. Army Research Project Developments, 23 U.S. and international patents. Probably more important, the technology's been in successful operation for 20 years. 5 years of that, we actually operated one of our plants 5 years continuously with no stopping for anything. I can tell you our first plant in Morrison, Tennessee, the first year we were in operation, we were certified by the state of Tennessee, the whole county, not our plant, but the whole county was certified as attaining 92% landfill diversion for the entire county. And then we've been evaluated by pretty much every third-party engineering firm in existence. So we have all kinds of third-party verifications and technology that we can share with you. Let's talk a little bit about a project in Murfreesboro. I know from some of you that have stopped by the booth, you'd either heard about the Murfreesboro project or maybe you're in the Tennessee area and familiar with it. So likely that's going to be our next plant. We have some others in development, but Murfreesboro is kind of out in front right now. It's going to be a facility processing about 160,000 tons of waste, 400 tons per day of unsorted municipal solid waste, and then another 50 tons a day or so of some food waste that's coming in. And so we'll be, like I said earlier, we're going to remove the metals, the plastics, the things that have a value for recycling in a given community. We're going to pull those out. We want to always use things for their highest and best purposes. And but we look at things a little differently when we're doing it. It's you know, we've got some projects in California we're working on, and the motto out there is MRF it first. You know, run everything through a MRF and capture what you can. And certainly we've got a MRF on the front end of ours, but our MRF is a little bit different in that we're not looking to primarily focus on the recyclables. We want to capture recyclables. We want to use recyclables. We want the money that comes from those recyclables, but that's less than 10% of the operating revenue for our facilities. We are really focused on keeping a clean stream of material in the process. You know, most MRFs are worried about grabbing, cherry picking, if you will, those plastics, the aluminum cans, the things that there's a ready market for. They want to keep that recycling stream extremely clean so they can sell it. Everything else is going to the landfill anyway, so who cares? But in our case, that other stuff that's going somewhere, that's where the majority of our revenues come from. So I didn't mention it earlier, but an important part of our projects typically is we're getting more revenue from the products we're selling than we are from the tip fees coming in. Now, that won't be true in every location. In a few places, tip fees are really high, but typically we're not basing our whole process on tip fees and recycling fees. So as we talk about Murfreesboro specifically, and the WastAway technology, I like to say it's a bit like a Swiss Army knife. We can mold it and make it to a specific community's needs. But talking about Murfreesboro, their base process, we're going to bring in unsorted municipal solid waste straight out of the packer trucks. We'll go through a MRF using various sorting technologies that some of you in this room will likely be providing. And we will be pulling out the recyclables that can be sold in that market. Next, we'll be going through our patented process with our cellulator, we'll talk about in a moment, that transforms the waste into something that's appropriate for anaerobic digestion. And we'll be going into anaerobic digesters and producing renewable natural gas. And we'll actually have more revenue coming from the renewable natural gas than we do from the tip fees for the projects. And then what's left over as the digestate comes out, we will be drying that material and reconstituting into a carbon-rich, sustainable fuel that we call SE3, and it will be going to a local cement kiln, reducing their carbon footprint significantly. For every ton of that fuel we use to displace coal, we save 1.76 tons of carbon. And here's some of Todd's numbers he always likes me to mention. So for a typical WastAway plant at 400 tons per day, that's the equivalent of taking 96,000 automobiles off the road from a carbon perspective. We're avoiding 866 billion pounds of CO2, and it's has the same carbon benefit as adding 517,000 acres of forest. And so huge carbon footprint advantages to our process. And some of the other numbers, I've already mentioned 85% landfill division. We've talked about the patents we have, been in operation for 20 years. 100% food waste processing for those of you that may be considering separate source collection for food waste. In some cases in California, we're talking to people where that's been required recently, and we're able to help them avoid that and not have to go to 3-cart and still meet 1383 requirements in California. Millions of tons of carbon emission reduction that we've talked about. And like I said, 400 tons per day is our typical plant size right now. Let's talk a little bit more about the process. I've already mentioned 2 or 3 times, we're taking 100% raw, unsorted MSW. We can take other inputs. If you already have a curbside collection program and there's only certain pieces of that material you're needing to get rid of, we can take it in and process it. Typically our plants are taking in 100% unsorted, the stuff out of the packer trucks, the stuff out of the black bins if you have a recycling program. We bring it in, we use various sorting technologies to separate it into its various constituencies. And then about 70% of what comes in will actually go through our cellulator process. And that's our proprietary process where we're using steam to transform the material. One important point in that, 30 minutes after the waste comes into our facility, or at least once it's loaded into the process, it's no longer classified as solid waste by US EPA and by most states. There are a few states that's a little different, but most states will accept that once the material's gone through our cellulator process, it's no longer considered MSW, and you don't have to adhere to all the various waste handling, permitting, and problems that come with that. And then about 70% of the material ends up going into some form of clean fuels. As I've already said, we're a bit of a Swiss Army knife. We can take self-haul waste, single cart collection, food waste, black bin waste, other similar waste. And then we go through the process and end up at the end. Now this is kind of our old process because we've added renewable natural gas as a new step recently. But in the old process, we took the waste, we go through the process, and we end up with SE3, which is our sterile, consistent, high-energy product, and that can be used to displace coal, wood, or other fuels, and dramatically reduce carbon footprints in the process. And you know, our plants, we always want to be a good neighbor. Our plants, there's no odors or noise. They're similar to any transfer station. Yes, there's going to be some truck traffic going and coming. You've got to get the garbage there somehow. But if you have an area that's permitted for a transfer station already, typically we can drop right into that site with very little permit modifications. And typically the footprints work out pretty well for handling the waste. We can actually process it on site at the transfer station and not have to go through permitting and new site problems. So let's talk about, as we've added renewable natural gas, we still have the same inputs, still using the basic process with our cellulators and sorting systems. Then we end up with the SE3 material that comes out. We actually put that into anaerobic digesters. We're working with Hitachi primarily, And in doing that in a high solids digester, and then we end up with about 50% of the material that comes in our solid fuel products. So yeah, I think I've already covered most of this. We're going to use the SE3 to produce gas. We can get, one thing that I guess is unique with our cellulator process is we are getting about 2 MMBTUs of renewable natural gas for every ton of incoming waste. Now, if some of you are familiar with anaerobic digesters, that may sound low compared to source separated food waste or something like that. But we're talking about not what's fed into the digesters, but of the tons of waste that hit the tipping floor, we're actually getting 2 MMBTUs for every ton of unsorted MSW produced into renewable natural gas. And that gas has been certified by University of Wisconsin. Their ERIC labs are kind of the anaerobic digester center of the universe, at least in the United States. We've had continuous digester operations since 2023 and have term sheets with multiple gas off-takers ready to purchase the RNG. I don't know that we need to talk about the digester itself that much. I assume most of you are familiar with anaerobic digesters, but we take the digestate in. It's basically kept in that, what you see is a large pressure vessel there. It's going to stay in there typically about 24 to 28 days. And as the material rots, for lack of a better term, it produces renewable natural gas. And then the digestate that's left over, that's what we screen, dry, and reconstitute into our solid fuel products. Pardon? Typically on a 400 ton per day plant, we're feeding about 200 tons per day into the digester. And so if you're talking about 20 days, you'd be looking at 4,000 tons if I did my math right. Yeah. In a typical plant, we would have 3 anaerobic digesters. Yeah. We can take small amounts of sludge. Quite frankly, the problem with sludge isn't processing the sludge. It's all the bad stuff in the sludge, a lot of heavy metals and other problems. So we can take up to 5% sludge, but we try to stay away from introducing too much sludge into the system. It's amazing what our pharmaceuticals and cosmetics do to our wastes. Pardon? No, with anaerobic digestion, we're methane is our primary. So I guess you could go to methanol from there, but we're producing methane as our primary output, and there are huge federal credits available for that renewable natural gas.
I got what might be a really dumb question, and I may have misheard it, but that's what I'm famous for. So you said the number of landfills is decreasing.
Mm-hmm.
Great. Who's making the decision to decrease the number of landfills without, or are they not making the decision as to what the next solution is? Does that make sense? Like who is it that's making that happen? And why is it that there's so many potential solutions? Why isn't there just a solution?
Okay, good question. And one thing about solid waste is it's not monolithic. It's very different across the country. If you're in California, Oregon, Washington, they've passed some rules there. California is called 1383, where they're forcing people to come up with solutions and not be able to send what's called the putrescent fraction, or the part that's going to rot and produce methane in the landfills anyway. They're forcing it to go somewhere else. So that's forcing a lot of projects.
Sorry, and that's where I'm from and involved in that a little bit.
Yeah.
Is that an example of the state saying, you're not going to do this anymore?
Right.
Figure something out.
That's what I would call regulatory coercion.
Yep.
And that's what's driving it in some locations. In other locations, in Middle Tennessee, where I'm from, the problem is we've got this huge landfill, it's closing, and nobody wants to be the site of the new mega landfill.
Gotcha.
And so that's citizens driven. Now, obviously regulations at some level are citizen driven, but in our case, just nobody wants to allow a new landfill in their community. So it's driven from both sides.
Gotcha.
Sometimes by nobody wants a new landfill. Sometimes it's driven by regulation. There are economies of scale with the large landfill operators have learned that it's easier to have one big landfill and transport material further than it is all these little landfills
Right.
like we used to have.
That was actually very helpful for my little brain. Yeah.
Yeah.
Makes sense.
Yep.
Any other questions? And we will have.
I have
Wow.
a question.
Okay.
Is it
Yeah.
100% methane recapture as opposed to like a landfill where they capture some, but not all?
Real good question, because, you know, at a landfill, and you can do methane gas capture there, but typically they've said they can capture, well, I've heard all kinds of numbers, but the models say they're capturing about 50% of what's produced in a landfill. California has actually been flying drones lately and testing that. Some of their latest research says they're probably capturing more like 15 or 20% of the methane at the landfills. In our case, we're doing all of this in a sealed vessel. And I'm an engineer, I'm never going to say we're 100% effective, but we're capturing virtually all of the gas. Because quite frankly, if we have any gas leaks in a pressure vessel, we've got a fire potential. So just from a safety point of view, we have to capture all the gas.
Great. Thank you so much.
Mm-hmm.
And we will again have a couple minutes at the end if there's additional questions or general questions. Last but not least at all, we are going to hear from Rodrigo Belisario. Okay, I'll let you pronounce it correctly. Sustainable landfill diversion and materials recovery.
Thank you, everyone. And Titan America and Rodrigo Belisario, and Director of Alternative Fuels and Raw Materials for Titan. We are a prime semi producer in the state of Florida. I have some interactive links here, so I'm gonna go with the presentation myself. First, I always try to bring alignment between the people that is present here, no? So if you look at the websites of the different people attending, yeah, that's how it holds. And everyone is very committed to the sustainability, cost-effective solutions. And if you look at the non-traditional organization or public organizations and counties, everyone is trying to do the right thing, no? And so do we. And Titan, Florida is the largest cement producer in the state of Florida. We have the largest cement plant in the state. And we do have the third largest square in the country with 12 million tons exploited every year, 60 ready-mix plants, 8 blocks plants. You probably have seen these trucks delivering concrete for us. And we have probably the largest logistic network across the state, no? We are a very entrepreneurship company. We have 100% low carbon cement. We are the only cement producer with 100% this type of cement compared to the others. And one of the highest thermal substitution rates, meaning the rates of how much thermal energy we replace with using waste instead of coal or natural gas or fossil fuel, no? A bunch of certifications, Energy Star, ISO 50001 for energy management, continuous monitoring of our emissions of what comes out of the stack of our process. And in the state of Florida particularly, all what we do can be considered 100% recycling because there is no byproduct or waste coming out of our process. Everything stays in the kiln. I'm gonna go a little bit into the process for that, no? And we operate all year 24/7. We'll just stop for maintenance outages. And the only thing is that we are not permitted for hazardous waste. Okay, you all have seen this hierarchy of how to deal with the waste. We are all familiar with it. If we can avoid to generate it, great. But the fact is that waste is generated, trash is generated, and there are different ways to deal with it. Co-processing, or what we do in the cement kilns, is just a combination of taking the energy value and the material or mineral value of the different ways that we can use or that are being generated, no? So instead of using coal or natural gas. It's not about competing against better alternative. We have heard about recycling, alternative chemical recovery, and all the stuff. But the fact is that the recycling rates are low in this country. The fact is that we need to do something now. It's not for later, it's for now. And this is already in place. The cement industry is well known for being a CO2 emitter. There's no secret on that. And nevertheless, we all are very conscious of what we need to do and reduce our carbon footprint. And these are the commitments that we have made to be net zero by 2050. No? Right now, we are right on track to that, about 570 kilograms of CO2 per ton of cementitious material that we produce. And we are very well aware, and the companies that we work with are very well aware of who is backing up our numbers. It's not only us saying what we have to do. No? Now, alternative fuels program is just part of our quest. It's not everything that we do. As we have our alternative fuels program and raw materials program, we have Separation Technologies, a Titan company that specializes in dealing with ash from coal power plants, okay? Whether it's in a fresh generation or it's a landfill ash or a ponded ash, there is a technology available developed internally by Titan. And we have the only cement plant with a real-time AI optimizer, meaning that plant is basically operated by AI. We have a couple of people making sure that the AI doesn't take the world over. But nevertheless, we have a very high technology operating the plant and making sure that we do it in the most effective way. Hydrogen, carbon capture and sequestration are things that we are working on. AI is another Titan company that specializes in AI for maintenance activities and for maintenance prediction. So it learns as the plant evolves. And these are a little bit our targets for 2026 onwards. No? Now, the cement manufacturing process, I'm not going to go, we have a lot of detail and we can go over later, but basically the limestone that is abundant in the state of Florida is crushed from the quarry to 3 inches minus, is mixed with virgin or recovered materials, meaning alumina, bauxite, alumina residues, silica, sand, or silica-rich wastes in a very energy-intensive chemical transformation process that goes to 600 Fahrenheit for the preheating process and about over 3600 for the clinker manufacturing process. And then the material is basically a man-made new mineral that is cold and ground with gypsum, limestone, and that is basically, can you go over to the original presentation? Sorry about that. And with gypsum, what we produce is basically a little new mineral, the little balls of a new mineral called a clinker that ground with gypsum and limestone and other materials is what you find in the Home Depot and Lowe's, the gray powder that you use for making concrete. No? When I said that the temperatures are high, it's really we're making lava. This is a man-made volcano, what we have here, where the temperatures are almost And these are for burning waste. These are the temperatures for making cement. So we're just taking advantage of a process that is already established to have lower operational costs. We don't use too much land. The plant is already there. And we don't generate any ash because, as I mentioned before, the ash is incorporated into the product that we make. And of course, we don't have any methane into the environment, the difference of other alternatives or solutions that are already there. Now, what are typically the things or the feedstock that are used in the cement plant? So typically, or what we do is merge residue, everything that is non-recyclable, that doesn't have any value. And it can be used as a source of fuel. And plastic, everything except PVC, that chlorides are not particularly good for the cement manufacturing process. We can deal with it in a bigger proportion. Nevertheless, we try to avoid them. And pretty much in jobs, best product can be in industry. Take, for example, use tires, it's something that we do. Use oil, dry biosolids from water treatment plants, carbon and roofing waste, and biomass, wood, yard waste. On the alternative raw material side, we also do the fly ash, as I mentioned before. We use it as a source of silica or source of alumina, foundry sands, meal head, copper fly for the different industrial process. The biosolids for the water treatment plants, they have a dual benefit. It can be a fuel, it can be a source of silica as well. Concrete waste, mining tailings, you name it. Now, what we do in our plant in South Florida and Miami, we are in the outskirts of the city of Miami. And in 2019, we started a process investment to install 150,000 tons per year capacity plant. We have all the toys that probably most of you can have heard about and that's all here, you know. We have primary shredder, secondary shredder, one of the people outside. Very compressed separation, which is the ready for it. Online monitoring of the quality, moisture, and review value. We are based on that, we are the most environmentally sound and most cost-effective solution. And the reason is that we take advantage of the mineral value, we take advantage of the thermal value of the waste, so that allows us. Although we have a lot of cost for pre-processing, shredding, and turning waste into a fuel. They call it SERC here. And we can take advantage of that benefit, thermal benefit, mineral benefits to reduce our costs. That's what put us ahead. A little bit of some other alternatives. And now what we are doing particularly in our cement plant here, we take all the mercury and residues, whatever cannot be sold and having value for the mercury operators, and commercial, industrial off-spec materials, and C&D materials, wood, plastics, textile, carpet, roofing, and plastic, again, as long as it have PVC or low PVC, we can take pretty much any plastic present without any sorting or very convenient. And any yard waste, biomass, agricultural baggings. Yeah, we turn all these mixed in different proportions, we produce an alternative fuel or engineered fuel. That is what we feed into that fuel. We call in the moisture, the temperature, the calorific value, and in the composition, the mineral composition. On top of that, we also use oil, collect and process use oil as a fuel for a kiln. And okay, so tires was a big problem. And then we do it in our plant as well. Now, what we have been doing lately, since we started with this program 10 years ago, we have processed over 175,000 tons of tire sheets. We get the tires, we have partners across the state that take those tires, remove the wire, chip it, and send it to us. That is equivalent probably about 18 million tires processed in the last 10 years at that cement plant, one single cement plant. As for the products engineered fuel, over 60,000 tons since we started this plant in 2021, and we turned waste into a fuel. That last year allows to replace 23% of our thermal load, meaning 23% of our thermal needs to run the plant, which is equivalent to about 150,000 tons of coal. If we were to use coal, we're coming from different wastes. We use oil, 3.5 million gallons since 2022 when we started with that. and over 2 million tons of fly ash, copper slag, and another residue from the industrial process, and thunder sands. Okay, so all the things that we have used in the past. And with that, do you have any questions?
So, I read an article on, blasted sand, and you mentioned that the, blasted sand, using concrete makes it stronger concrete.
The glass has some functional properties. When ground fine enough, it can replace some cement in the concrete, in the final mix. That is correct.
If you had that product, would you be interested in
If, of course, it's out of the right price and definitely at the ground, the specs that we needed, that's definitely something that we could use. When the volume is enough, it's a recipe that we need to apply to the concrete, but yes, it's something that is not new, can be done, and we have been exploring as well.
fiberglass on
If shredded, yes. Actually, with that is done, and one of the projects that we have been putting our head on is the fiberglass from bolts, because we know the landfill want it, it's very bulky, no weight. And from the wind turbines, the wind turbines are a very good example. That is done by a company. The problem with the fiberglass is the process. Take it down to a 2-inch diameter or 1.5-inch diameter. It's a process itself, it's sandpaper, it's dealing with sandpaper. But if the material is put it into that specs, that will be kind.
Running where you use your limestone and other aggregates materials, but do you see any alternative concrete into that? And how much is that? Possible?
Yeah, we do use ground concrete as an aggregate, and in our supply chain, we're vertically integrated. So we work from the production of the extraction of the raw materials down to the end product for the customer, the concrete. That is the great thing that we use in the sidewalks and buildings. And yeah, all these materials go there. The concrete particularly goes into that as an aggregate for the concrete, for our concrete plants. And there are other CND materials that we take from construction and demolition, like the gypsum is a project that we are looking for. And the drywall, once you take out the paper, basic gypsum. And for example, the water treatment plants, and they take out the magnesium and the calcium, they produce a very fine precipitated limestone. Okay, that is something that we incorporate also in the manufacturing process as well. And yeah, pretty much everything at the end we use a little bit of everything to find the right chemistry for our products. But if that is inside a waste, we can use.
That seems the fresh concrete would be more used in the ready-mix plant.
Yes.
And they do concrete, not the cement plant.
Yeah.
Thank you.
Any other questions for this presentation or any of the presentations for the entire session? We've got a couple more minutes. And for any of the presenters.
Replanning a building of the plant.
But put it together as a net plan is pretty high. in the pretty difficult in the US right now. We have a very strong network, a very strong capacity. We have a lot of capacity in our plant, again, 450,000 tons per year capacity, just processing capacity. We have, for example, the tire chips. That's another capacity for 100,000 tons of tire chips in addition to the 150,000. And we still have our cement, still have spare capacity for about 9,000 tons more. So we could reach easily 250,000, 300,000. We are using right now probably a third, 25% of that capacity. As we build the market and we bring our supply chains of different ways into our process.
So are you accepting materials inbound on reactor?
Yeah, we have rail capacity in our cement plant, and both for liquids and solids. So
Okay, any questions for the entire session? Okay. Can anyone tell me one thing they learned that they didn't know before they got here? Yes.
You have the circles of tape items.
And I still do it, I feel horrible, they're all in plastic packaging too, but no, seriously, come on, share something that somebody learned.
Very good.
I learned about my own president, about the fact that, you know, our government is mandating things stop without necessarily mandating what, sorry. That also, which means a lot of opportunity for all of us. I also learned that not always government mandating something, sometimes it's just logistics, business, citizens and so forth. There's a lot of different reasons things have to stop. What else? Can I give you one thing and then I'll let everyone know? I don't know, lock the door or not. Somebody shared the criticism value here. Educate somebody.
Plastic recycling on the truck, the trailer of the truck was interesting, other than, Eastport, Tennessee, your East Coast, who did gas chemical molecular recycling of plastic, so it looks a lot different than what I'm used to, so, that's great.
Awesome. Me as well. Enjoyed that. Okay, if there's no more questions, we're gonna end about 10 minutes early.